Hello students, this is Karthik. In this academic year, I am taking Structural Engineering 1 RCC for third year BTech first semester. So RCC is a subject which is involved in structural engineering. Basically, structural engineering consists of two subjects. So one is RCC and second is steel structures. So in this first semester, you will be learning about the design and detailing of RCC structures, and the second semester will be dealing with the steel structures. So this slide gives you the overview of the syllabus. The first part will consist of the introduction of RCC, what are the design methodologies which are involved in it, and the beam design will be there. In continuation the beam design, the second unit will be consisting of design of shear and bond, and also design of the beam against the torsion. By progressing to the next units, in the unit 3 you will be learning about the design of slabs, which perhaps designed as a 1 meter width beam. So types of slabs you will be dealing with, and also design of staircase you will be learning. In the fourth unit you will learn the compression members, which is columns. There you will deal with long columns and short columns, and also axially loaded members, biaxially loaded members you will be learning. In the last and final unit will be compressing of design of foundations, where you will be learning about design of wall foundation, square foundation, and circular and combined loading. So this is the overview of the syllabus. So if you take a look of all those pictures, starting from left hand side to right hand side, we can put them in a single verb, which we call them as a structures. The evolution of structures began in the 19th to 17th century, where the huge structures are designed only for the temples or ritual purpose. But their progresses, the structures evaluated, the design became more complexity, and so called, if you can see the right hand side output, the picture is from the Mumbai, where you can see these skyscrapers. So the purpose of living made all this invention. So in the first part we will be learning about the introduction. So in introduction we will be learning about what actually structural engineering is there, what actually structural engineering is all about, and you can see in the picture, this was the picture taken in the Shanghai, where you can see this series of skyscrapers, where you can also see a few buildings there. You can see the park, you can see a transportation, multi-level transportation. These all structures, we can term them as a single point, saying that these are all structures, but basically those are defined with a certain purpose. The purpose who will deal with these are called as structural engineers, and the discipline is called as structural engineering. So you can see the design of these buildings purposes the bones and the muscles for the structure. So if you want to design the bones and the muscles of any structure, you should be very sound enough in applying the theory of mechanics, right, and the laws of the physics. So not just that, the structural engineers also need to understand the stability and the strength rigidity parameters of these structures in order to make them as habitable. And third and last, which I would like to close this slide, is that I have said before, the structural engineering consists of mainly two parts. One is the structural engineering dealing with RCC material, and the structural engineering dealing with steel. So in this subject, we are going to deal with the structural engineering with RCC. So this is the timeline discovery which I would like to share with you. This is out of syllabus, but in spite of that we have to learn about this. So in the late 18th, 16th or 16th century, the Leonardo da Vinci was the first person who made his first contribution to the laws of physics of dynamics. So later on but he failed to, he able to draw these figures, but he able to propose things in a scientific manner. So these scientific explanations were done in majority in 17th century. Euler-Bernoulli's theorem, which we call it as EI d square by dx theorem, was done in 17th century. Then on the date progresses, and the complexity which is the 16th and 17th century was solved in 18th and 19th century. So how do you define a structure? Structure generally defined as an arrangement of relations between the parts or the elements of something complex. If you have a complexity of anything, and if you are putting them in a systematic manner, so that is called as a structure. So in the figure it shows you plainly. So you have data structures in computer science, you have power structures in electrical. So what does the deal is, there is a complexity in it, and the complexity, if you solve it in systematic arranged way, that is what is called as a structure. So in civil engineering, if you are calling it a structure, our structure defines as a building or any object which is constructed from several parts. If you can see in the figure shows you the cross section of the building, where you can see the slab, you can see the columns, you can see the foundation, you can see everything. So this structure, the entire structure is consisting of several parts, and if you put them in a systematic and arranged way, then that is called as a structure. So can we define a floor which is mixed in water as a structure, or a wet clay we can say is a structure? Yes, we can say, because it has some definite shape to it, which we can mold into any shape, which we can do anything which the user wanted to have. Now we shall proceed with it. So what does it mean to construct something? If you want to construct something, say, let's take an example of the left side figure. You have people who are carrying some materials, background trees, you have some other materials. If you want to list out them, so we can list out the first as materials. Like we can see the wooden blocks, the backdrop, then you can see the sand there, then you can have clay, you can see some bricks there, then you can see cement bags, you can see ropes. So these all materials, and if you can put them in a systematic arrangement, like the right side figure which you can see, like the wooden blocks became the truss members, the bricks became the covering of the building, the wood became the doors and windows. So these all materials not just include by itself, we need to have some manpower in order to make this happen. And the manpower, essentially you can see that the masonry is very necessary in order to have a masonry covering of the building, and we also have a very important carpenter who makes tables and these things. So, and in helpful masons and carpenters help us one much necessary. You can see there the wooden blocks are not just with the machinery, but they are treated manually. So these are all does not involve with materials and manpower. You need to also have a machinery, tools and equipment. Without this building wouldn't be possible at all. So the main concept which I would like to say from this slide is, you have a set of materials here, right? You have a set of manpower, and if you have a machinery, tools and equipment, you can build a structure, right? So you can see in the right side figure, you can have a chair, right? And a person is sitting on the chair. Can we call, what is this called? So we call this as a chair. And what is this used for? It is used to rest a person, or if you want to sit, you will use this chair. So can I ask this question, can it be used to keep certain things in one place so that they cannot lie around all over the classroom? I repeat the question, can be used to keep in a certain things in one place so that they do not lie around over the classroom. So we cannot use this, right? So the chair is used only for the purpose of sitting, right? So if you want to place few things in a single place so that it could not lie around, is what we use tables, right? So table is a structure. Now here the structure is the chair. Now this third last one, can be used to protect something, for example to protect you from sunlight. Can we use chair to protect us from sunlight? No, we cannot use. So different structures is designed or constructed to serve a certain purpose. So last question, is it used to support something? Yes. Can I use chair to support a table? Right? So it is not defined, you can use it, but it is not defined for that purpose. So whatever I am calling this as, so these things which are making to serve our purposes are nothing but our structures. So continuation with structures. So you can see in the figure, what is this figure? So this figure, this is also one of the structure. The questions which we can have is many, like the same questions, what is its purpose, what is it made up of, can it be used to support something, the same questions we can ask. But this structure serves only purpose to move around from this position to that position, because we have been obstructed with a small river or a drain. So basically the bridge serves for that purpose. So in continuation with that, if you really want to understand about what is actually structure, if I give a small business situation to you, like I wanted to set up a stall. I have maize, I have sugar bag, I have flour bag, I have eggs, right? I have oil. I wanted to set up a stall. Now, please list out the whatever things you see in this picture, right? Now, if you want to set up a stall, what else do you need to set up now before you want to sell the goods, right? These are the questions you have to make it. What type of the container will eggs you sell come, right? Why are eggs packed in special containers such as the one you see in the picture? Why can't we hold our eggs in our hands, right? You cannot hold your eggs in the hand, right? Why? The reason is when you cannot have eggs in your hand, you can sell the goods, right? You need to have certain container to place it. Now that container, which we call as egg placer, is a structure which is used to hold the egg, right? So if you want to make a table from two empty crates, the crates as shown in the figure, right? So if you want to make a table in the stall, you can use the crates itself, right? So suppose a woman wants to buy 2 kg of flour from you. If you are in stall, let me say, and suppose a woman came and you are supposed to give 2 kg of flour. So will you ask her to hold out her hands so that you can put it on her? No. So will you make any other plan? So these are all the questions you need to make. So will you use the containers which you sell maize, rice and flour to the people, right? So will you use any other containers? So these are all the business questions which we need to ask. How to sell the oil again? What you decide to use a span across the crates uniformly table when you answer the question previously, right? So you want to design the table, but you wanted to have a support. So how do we design it? So all these questions can be answered in a simple way. The crates can be used in order to make a table or a container, right, in which you can store an eggs. The plastic bottles which you can use to sell the oil. These are all combined, or you can simply say them as structure. Even a water table, empty bottle is also structure. A container is a structure. Table is a structure. Chair is a structure. Anything which is complex in nature, which serves our purpose, is defined as a structure, right? So I need you all to draw a stall, which will be your first assignment, right? Take few vertical posts. Now remember, you should also cover your stall, in order to serve the purpose from rain and this thing, right? So ensure these things. So in this business situation, if I want to conclude it, in order to contain or in order to hold anything, right? There are structures to serve this purpose. The examples can be as plastic table, paper bag, right? Egg tray. These are all structures which are used to contain or hold something. Then you have to protect something, right? Your stall will be there. You want to protect from rain, and that is what the structure which we call as a roof. Then, in order to have this roof, you need to have vertical posts, right? So these posts are also called as a structure because it is serving the purpose of supporting something. And the vertical members, right, which making you the post not to get away from the stall, those are called as beams, which are under flexure we call. So these are the different parts of your stall which are serving different purposes. All these combined, we are making them and putting these in a stall, which we call it as a structure. So if you bifurcate, if you define the types of the structures, basically the structures are bifurcated into 2 types: natural structures and man-made structures. So natural structures which you can see naturally, so like you can see here the ant made shell. The man-made structures you can see whatever we are doing to serve this own purpose, those are called as man-made structures. So we'll go through in detail with them. You can see in the figure you have 6 figures A, B, C, D, F, right? You just need to classify the type of the structure, right? So the first A figure is a man-made structure, B is a electrical transmission tower which is used to transmit the power from one point to another point. It is also man-made structure. C is a wooden logs, right, which is available directly from the forest. It is a natural structure. D, which is a small shell where we take shelter, right? So that is a man-made structure. The skull of a human, this is a natural. The egg is natural. So A, B and D are man-made structures. C, E, F are natural structures. So you can take these figures and you can start your own work, like what is this, man-made or the natural. So these figures are for you. You can work it out by yourself. So types, the structures, not just the previous slides we have learned about the structures which are defined based upon their origin. Now based upon the function, the structure also bifurcated into 4 types, right? One of them is a solid structure, right? Like dams we had, right? That is a solid structure. The second type is a framework, right? The trusses we have, like the skeleton, it becomes a skeleton of the structure. So that kind of thing is a frame structure, which we can say network of parts to support something. Then you have a shell structure, right? Shell are nothing but a hollow structures with a curved shape so that you can, which have huge strength and rigidity, right? And fourth one is combined structure, where we use a solid structures and a frame structure and extensor combined together. So basically 4 types are there based upon the functions of the structure. One is solid structure, second is frame structure, third is shell structure, and fourth is combined structure. So what are the components of the structure? If I define based upon the load bearing, these structures can be defined or bifurcated 2 types. One is non-structural components and second is structural components. If you take a look of our own building, all the structural components are not the load bearing oriented. Some of them are load bearing oriented, some of them are not. Load bearing in the sense, the structural member which carries the load, right? So for example, if I take a parapet wall which we construct above the slab, right? So that is a non-structural component. In the same way, doors and windows. Doors and windows serve the purpose of ventilation and airflow, right? Third is furniture fixtures, like you have tables, chairs. These are all not taking any load to the structure, right? Fourth is partitions or partition walls, flooring and finishings. All these 5 which I have listed out here. There are few more which I have not listed, but so these are all non-structural components. When it comes to structural components, your foremost thing is the foundation. Second thing, the column, RCC walls, shear walls, piers, right, slabs, beams, staircases, which lintels, right, weather shades. These are all comes under structural components, which essentially carries all the loads and transmits to the foundations. So based upon the load bearing, the structural components, non-structural components are there and structural components are there. So take a look of this figure. You have 2 figures here. The both figures are of same purpose, which is the storing of a tank. In the figure to the left hand side, there is a tank with a masonry base. To the right side, there is a water tank with a skeleton base, right? So my question is, which stand is a solid structure and which stand is a frame structure? The second question we would like to raise is, which stand do you think is stronger of the 2, and explain why you think so, right? So this is your second assignment which you like to say. So this is the extension of this slide, right? Non-structural components, structural components, and their importance to it comes from this slide, right? So moving forward, you can see there figure, you can see the structures, right? These structures are of different shape, right? This is the UAE, this is in UAE, this is in Europe, right? That is in China, right? So these all became the icons of their country, right? Just not because of non-versatility in the structure. It is not eccentricity at all. Now it is other than the designer designed himself in a way that it could attract and it could be in a place where they could be recognized. So the bottommost figure you can see the fish building which is in Hyderabad, right? That is fisheries department of government. So all these buildings which are out of shape should essentially meet all the four requirements which are listed below. One is stability, safety, equilibrium, and also mainly compatibility. We are going to talk about that. So what is stable equilibrium? Take a look at that figure. I have a black ball, right? So if I have a plane surface and if I place a ball at any location, if I even place it, it will not move around from its position, right? So at that position, that body or the structure is said to be in neutral equilibrium. Now this happens only if the surface is plane. Now take a look at the next figure. Now if I have a curved shape, right? And there is only one position in the entire curvature where your body or structure can be equilibrium. And if this is the position of your structure, then that is called as an unstable equilibrium. You can never predict when your structure is equilibrium. It always, it moves away from the place. The third figure I would like to say is stable equilibrium. So wherever you place your position of your ball, it comes to the equilibrium position, right? So this position is called as a stable equilibrium. So there are three equilibrium conditions. One is stable equilibrium condition, second is unstable equilibrium conditions, third is neutral equilibrium condition. So often most students will confuse about what is equilibrium and what is compatibility. So equilibrium or equations are nothing but when the external loads applied is equal to the internal loads, then the condition is said to be equilibrium condition. I repeat, when the external set of loads is equal to the internal loads where the body is still in the equilibrium, then that state is called as a equilibrium state of condition. Whereas in compatibility conditions is with the continuum of the mechanics where only the force is applied and you have a displacement to it, right? And displacement has a certain parameters, like this end point has a 0, this end point has a 1 mm of unit. If you knew it before only, that is a compatibility condition where it can be defined only with the definite shape which is unique to the body, right? The equilibrium conditions also stress resultants and the force movements are the equilibrium conditions, whereas in compatibility condition, which always refers to the force and the displacements of it. So perhaps from these two bifurcations or the differences, we can see it as equilibrium is essential but compatibility is optional, right? Even you can change the compatibility conditions by choosing another kind of a support, right? So in continuation to it, if you have a force which is subjected to any body, the combined you will get stresses and the strains, right? The forces and the stresses are directly related, which we call them as a equilibrium equations, right? And the stresses and the strains, they have a constitutive relation because there is always a force. You can expect both of them. That is why I said a constitutive relation, right? Because of strain, right? Because of force, there is always a displacement, and the displacement is directly related to strain, and that relationship is given as a compatibility equation. So I am sure that you will understand from this. So forces, the equations which are defined between forces and the stresses are called as equilibrium equations, and the equations which give the relationship between displacement and the strain is called as a compatibility equations. So I have a small video for you. So we have learned about equilibrium, we have learned about the stability. Now what happens if your structure is not stable, right? There is a bridge which is constructed in US, right, which connects from San Francisco. So it is constructed November 7, 1940. It was failed due to aerodynamics instability. Your structure is good, you know, the vehicles are moving, right? It is not having any deflections at all. But due to the lateral load which came from the wind, the entire deck slab started to wobble. And it increased even though the wind is reduced. So, and ultimately entire building collapsed. This is the stability failure, not the equilibrium failure, right? The instability happened because there is a lateral load which was not considered in the design part. In the right side figure, you can see a bridge which is of steel, right? Which is also which is in Canada, Quebec bridge. That is a reconstructed bridge, but the original bridge was failed due to the failure of the truss member, which is pure. Right? The designer did not cope for the calculated the static loads, but the erection loads he did not consider. Right? Due to that erection loads, which created instability in the structure, the entire structure collapsed. So these two are the examples. If you ask me, what are the failures due to instability, right? So instability is also the foremost thing which we as a structural engineer need to consider it, right? So coming back to the loads, right? So the next few slides will discuss about the loads, right? So the loads can be defined bifurcated into two types. One is the static load and one is the dynamic load. Static load is a load which is a constant at any period of the time, whereas dynamic loads which are not constant, right? So examples of the time variant loads are wind loads and earthquake loads, which we cannot predominantly estimate them. Rather, the static loads we can estimate them, and those are bifurcated as one is the dead loads, right? Second is live loads. Dead loads are the stationary and permanent loads which will not move, right? These include the self weight of building members, beams, columns, slabs, concrete, brickwork, flooring, etc. And if you want to know the dead load of any concrete brickwork, then you can refer IS 875 part 1. And live loads are which are not stationary, not permanent, right? These are change in magnitude, right? So the example for this are people which are moving, or the occupants of the building, the furniture, the air condition, the facade which we usually apply to the front side of the building, right? So these all the live loads depend on the type of the building. For institutional building it is a different load, for commercial building it is different, for residential building it is different, because it depends upon the type of the occupants and the type of the furniture. And the live loads for which building what we need to take, it is clearly mentioned in AS 875 part 2. These two we can tell them as the static loads. When it comes to dynamic loads, which is a time varying load, there is wind load. So wind depends upon region, wind depends upon the surroundings where the building is. It also depends upon the terrain and the height of your building. There are many factors if you want to calculate the wind load. So wind loads are large projected areas. When you have a huge building, the wind load is a major load which is coming up, which we have discussed in the previous slide when it comes to instability. So your bridge is very long and you did not consider the lateral wind load, and that became instability and complete failure also. That can happen to the building also if you are not considering the projected area of your building. So it is a substantial force because the collapse is immense and you can never predict the amount of it. And IS 875 part 3 exactly shows you and tells you how to calculate the wind load and how it depends upon the building location and everything. They have clearly mentioned it. Last but not least, we have earthquake load. Sometimes it is also a seismic load, right? So it is a lateral live load which we come across due to the motion of the ground right, due to the release of the energy due to two tectonic plates colliding each other. So it is very complex and very uncertain to calculate, to estimate the amount of earthquake load which is coming. So basic on the previous history, we will take it and we will modulate it and we will simulate it, we will calculate it. So it can be done that also. It can be even calculated from AS875 part 1 2002, where they define the same things which the wind loads they have defined, and you can calculate the lateral loads or seismic loads from it, right? And these are also the lateral loads, right, other than the wind loads, which causes more damage to the structure and huge life loss also. So the four loads which we have said before: dead load, light load, wind load and seismic load. Four loads we need to consider and we have to design the building. No matter, even though your building is not having a load, we have to consider it for our safety purpose. So carrying on, when we are this subject mainly deals with RCC, so you need to know the materials and the design part of it, right? So what are the different types of the materials which we come across in RCC, right? We have steel, we have earth block, clay brick or ACC block, we have concrete, we have cement, we have aggregates, we have doors and windows, we have finishing, we have electrical plumbing, we have moisture and thermal insulations, which we often call as HVAC. So we combine these all materials in order to make our structure, right? The figure, the infograph which shows you is the cost of a building for 1000 SFT, not in Hyderabad, but it is calculated in 2014 in Pune. You can clearly see there the majority of the expenses for any building goes to the steel, right, which takes about 25% of the cost, right? But most oftenly the estimates will underestimate the amount of the expenses towards the fittings which are sanitary, right, or sanitary or doors and windows. That takes about 22% of enter, which is almost 3% less. So this infograph shows you an idea of how much volume of materials you need to have. The cement is about 16%, 12% is about sand, and 7.4 is about gravel aggregates, right? So what is mean by a design? So design is a specification for any construction of a structure. If I give an example of design a chair, now what you will give? You will give the height, breadth, depth, material, sizes, right? What is the load which can carry? So these are all the specification you need to have. So design basically it's a common term which is used in all engineering streams, right? So these designers are what designers will give the specification of a structure. So in our civil engineering we call that structure as a construction. So designers designers are also available in many fields. Like you have, for example, if you are designing an RCC beam, right? And you will give what? You will give the width of the RCC beam, you will give the depth of the RCC beam, then you will give the steel details, number of bars you needed to have, right? The stirrups, then steel arrangement you will give, you will provide the diagram neatly, right? And the material properties, what is the material you have taken for that RCC beam. So designers are basically these people will give the specification for any structures, right? So the people who does designs are called as a designer. One who's involving in structure will call as a structural designer or structural engineer. So there are, if I can ask you name any 5 types of designers, you can say textile designer. Textile designer will design the clothes and everything. Next we have fashion designer, we have product designer, mechanical, we have concept designer, right? Events, if you have, then you have the concept designer, then you have web designer who basically designs any website, then you can go on, you can have interior design and so on, right? So if you take a look at this picture, right, there are mainly 2 types of materials which we come across in RCC. One is in entire structural engineering, one is RCC, another is PSC. So what is RCC? RCC stands for reinforced cement concrete. The later part is cement concrete. You already dealing with the concrete technology. We are reinforcing the concrete technology because cement concrete is lacking in some strength parameters. We will learn what it is in lacking, right? The second thing is PSC, which we call pre-stressed concrete structures. I will give a hint of pre-stressed concrete structures. If you take a look of the picture, the first picture which you see is a bridge and there is a truck which is moving, right? Now when your truck is moving and if you increase the weight load of the truck, right, what will happen is your beam will start to bend. When your beam starts to bend, the bottom portion of your beam will start to give the cracks, which is shown in the second picture, right? Now in order to avoid the cracks in the concrete, what we do is we will strengthen the cement concrete by providing these bars which we call as steel bars, right? The concrete will be reinforced with strengthened steel bars. Now what if I remove the steel bars? Now I provide the steel wire, not steel bar, steel wire, and I stretch it. Now this stretching will induce the stresses before it was loaded. So that is why we call it as a pre-stressed concrete structure. So in pre-stressed concrete structure, the cement concrete is pre-stressed before loading it, so that your vehicle can travel smoothly, right? This you will learn in PSC, which is a completely different subject. So moving ahead, in structural design, if you want to design anything, there are stages which you need to follow, right? One is you need to have a good planning, structural planning you need to do, right? Now the water tank should be constructed, then slab, then beams, then columns, then to the foundation. This is the structural planning, and you need to collect a lot of data. What is the building purpose it is, right? Or how much is the occupancy, what is the area, and so forth. Everything you need to collect it. That entire process is called as a structural planning. Next is the action of these forces and the computation of the loads, right? You need to do that. Next, you need to preferably follow one method of analysis in order to evaluate the bending moments, the shear forces and everything, and stresses. To that stresses, you need to pick up materials, RCC, right, where we have cement, concrete and steel, and you need to provide certain area in order to your structure to be stable, right? That comes under member design. Member design not just involved in that construction. After member design, you need to go for detailed drawing in order to execute on site, right? These are the 5 stages which are involved in structural design. Last slide, we're going to close this session. Now, how do we plan these structural elements? First is you will have the columns, right? You will position and orient the columns. That is your first plan, right? Second is you will position the beam so as it will connect mostly the columns. The columns to column, we will join them. That is what we call it as a position of beams. Third is when you have the beams, you can have the spanning of the slab. What is its X length? What is its Y length? Right? When you have slabs, when you have beams, right, you can lay out the staircases and the column members, right? Then you can have a proper type of footing. So the structural design will comprise of these 4, right? But the elements which are involved in structural element involves in these 5 stages, which is position of orientation columns, position of beams, spanning of slabs, layouts of staircases, proper type of footing. In the next class, we will learn about this beam design and the material characterization. Thank you all.